So now we will start the procedure to trace Cartesian curves. Actually, Cartesian curves are given in terms of x and y. So all equations of Cartesian curves are in x and y. So we have written here f of x comma y comma c is equal to 0. It means this is the equation which contains x, y and some constant c. The first point under this procedure is symmetry. Total there are 6 points. The first point, it is symmetry. Second point, it is origin. Third, points other than origin. Fourth, it is asymptote. And fifth one, it is region of absence. And the last part, by considering first to 5, you have to trace the curve. So we will start the first point, that is symmetry. Again, in symmetry, there are 5 subpoints. The first one, it is symmetry about x-axis. So how we are going to check whether curve is symmetric about x-axis or not? For that, here condition is given. If the equation remains unchanged, by replacing y by minus y, then curve is symmetric about x-axis. For example, here I have written y square is equal to 4x. So friends, if I replace y by minus y, then what will happen? As here in the square, it will remain y square, and then 4x, it will remain as it is. So after replacing y by minus y, this equation remains unchanged. Therefore, this curve is symmetric about x-axis. And here I have drawn this figure. So this is parabola open towards right, and this is symmetric about x-axis. Symmetric about x-axis, it means 50% curve, it lies above x-axis and 50% below x-axis in same manner. The next symmetry, it is symmetry about y-axis. How to check whether curve is symmetric about y-axis? So condition is given. If the equation of curve remains unchanged by replacing x by minus x, then the curve is symmetric about y-axis. So for example, x square is equal to 4ay. So this is parabola open towards upward side. So in this equation, if I replace x by minus x, then what will happen? After replacing x by minus x, because of this square, it remains x square as it is, and this 4ay, it will be as it is. So after replacing x by minus x, equation remains unchanged, and therefore the curve is symmetric about y-axis. So this is the parabola open towards upward side, and this parabola, it is symmetric about y-axis. The next point of symmetry, it is symmetry about the line y is equal to x. Friends, what is the line y is equal to x? So this dotted line represents, and its equation is y is equal to x. Now the condition is, if in the given equation, if we replace y by x and x by y, and if equation remains as it is, then curve is symmetric about the line y is equal to x. For example, if I choose the equation as xy is equal to c, so just now we have studied that xy is equal to c, it is the equation of rectangular hyperbola. So if I consider xy is equal to c, when I replace x by y and y by x, what will be this product? Yx, but yx can be written as xy. So after replacement of y by x and x by y, equation remains as it is, and therefore this curve is symmetric about the line y is equal to x. So this is a rectangular hyperbola which is symmetric about the line y is equal to x. Okay. Point of symmetry is symmetry about the line y is equal to minus x. So friends, what is this line y equal to minus x? So this dotted line which I have drawn here, this line, its equation is y equal to minus x. So how we are going to check whether the given curve is symmetric about the line y equal to minus x? So the condition is, if the equation remains unchanged by replacing y by minus x and x by minus y, then it is symmetric about the line y equal to minus x. For example, suppose xy is equal to c. So it is a rectangular hyperbola, it is known to us. If I replace x by minus y and y by minus x, what we will get? Minus y into minus x is equal to c. And this is nothing but xy is equal to c. So after replacement of x by minus y and y by minus x, this equation will remain as it is, and therefore this curve is symmetric about the line y equal to minus x. Now if we see this figure, so this is the line y equal to minus x, and this is a rectangular hyperbola which is symmetric about this line. The next sub point is, so point number E, symmetry in opposite quadrant. How we are going to check whether the given curve is symmetric in opposite quadrant? So friends, opposite quadrant means curve is symmetric in first and third quadrant. Curve is symmetric in second and fourth quadrant. So the condition is, if the equation of curve remains unchanged by replacing x by minus x and y by minus y simultaneously, then it is symmetric in opposite quadrant. For example, again we take same example, that is xy is equal to c, and which is rectangular hyperbola, so that I have drawn here. If in this equation xy is equal to c, if I replace x by minus x, y by minus y, but again its product is xy. So after replacement, again we get same equation, and therefore this curve is symmetric in opposite quadrant. So if you see this diagram, 50% curve lying first quadrant and 50% curve lying third quadrant, and therefore it is symmetric in opposite quadrant. Especially if I take the example of circle. Now see here, x square plus y square is equal to r square. So this circle, if I see, I can check all type of symmetry. The first symmetry is, this circle is symmetric about x-axis. Why? Because if I replace y by minus y, equation remains as it is, and therefore circle is symmetric about x-axis. The second symmetry is, if I replace x by minus x, again equation remains as it is, and therefore this circle is symmetric about the line or about the axis y-axis. If I replace x by y and y by x, that is third point of symmetry. If I replace x by y and y by x, again equation remains as it is, therefore this circle is symmetric about the line y equal to x. See here. So this circle is symmetric about this line also, because on this side 50% circle lies, and again on other side 50% circle lies. Therefore this circle is symmetric about the line y equal to x. The fourth point of symmetry, it is symmetry about the line y equal to minus x. So if I replace x by minus y, y by minus x, again equation remains as it is, and therefore this circle is symmetric about the line y equal to x. So if I draw the line y equal to x, so this will be like this. So this circle is symmetric about this line, and equation of this line is y equal to minus x. And the last point of symmetry, symmetry in opposite quadrant. If I replace x by minus x, y by minus y, equation remains as it is, and therefore this circle is symmetric in opposite quadrant, first and third or second and fourth. So circle is an example which involves all type of symmetry. Okay. Now we will proceed further for second point.